Right, so let's wait 2 minutes for the others. All right, so 2 minutes is already over. So let's go back. Okay, let me just check if you guys are already in front of your computer. So just give me a quick thumbs up. So let me know that you are already ready. It's a quick thumbs up. Okay, so you were 4 out of 9 or out of 8. Where the others? Maybe we went to CR. Anyway, so let's go back right here since I think I um, interpret this one incorrect. But it says here that while creating, you should aim for high cohesion or cohesive component or module that focuses on a single function or single-mindedness, which is correct if we are going to describe that one as in terms of cohesion, since in coupling, you're connecting two modules with each other, so they are depending with each other. While when we say cohesive, so it's already or cohesion, it's already given that it doesn't work with other module, wherein it's really only focusing on its own module. So that is why it says here, as much as possible, should be a single function or single-mindedness with little interaction with other modules of the system. So it says here with little interaction with other modules. So it is not talking about the other module. So as much as possible, you should avoid this connection, right? But once we do this one, this is not cohesion anymore. This is already coupling, right? Because you are now dealing with two modules. So I guess the main point of this one is you must not have this coupling. Right? Of course, it's obvious since we're talking about cohesion only, since only dealing with one uh, module. Anyway, I hope this one is now more clear to you guys. It's just that I think it's already given. Of course, we must only focus on that one module. So I guess I have to update this one, okay, later on, or we'll try to seek help or ask Ma'am Teresa, okay, regarding this one. Anyway, so let's now move on to the functional-oriented design or function-oriented design. So function-oriented design is a method of software design where the model is decomposed into a set of interacting units or modules where each unit or module has a clearly defined function. Thus, the system is designed from a functional viewpoint. Okay, so this one is similar with the partitional problem partitioning or the modularity. It's just that in here they call this one function-oriented design because you're now dissecting or you're now separating them via function. Okay, so we have some design notations right here wherein primarily meant to be used during the process of design and are used to represent design or design decisions. For a function-oriented design, design can be represented graphically or mathematically by the following. So we have the DFT or the data flow diagram, and then the data dictionaries, and then structured charts, and then the pseudo code. So let's start with the data flow diagram. So in here, I guess this one is you guys already know what is a data flow diagram because we have already discussed this one. But a data flow diagram is concerned with designing a series of functional transformations that convert system inputs into required outputs. Or in other words, in here you'll be able to monitor the data or where does your data flow, okay, from this point to that point, okay, from to the user to the database to the system itself, and so on and so forth. Okay, so here are some notations that you need to take note when it comes to DFD or data flow diagram. We have the rounded rectangle. So this one represents function which transforms the input into an output. Okay, rectangle is just a data, okay, or a storage. Circle is just a interaction, okay, wherein mostly this is the starting point, okay, and then the ending point or the let's say continuation. We also do that one in a circle. Then arrow is of course it's to show direction, and then end and or are the some keywords of course. So these have the usual meaning in Boolean, so nothing special. So end is end, or is or. So those are the symbols that being used when it comes to creating a data flow diagram. Okay, so this is an example of a data flow diagram of design. So we have here the start and then the end. And then we have here the rectangle one, which is again this database or storage right here. And then we have here the rounded rectangle, which is a function, okay, or it transforms a certain data into a certain data. It could be from, of course, from input to output, or it just simply converted one from this data to that data. So yeah, depends. So in here, get design name, of course, it will be getting the entity name from the database and then sort the entity, look up entity, sort, and then produce the link report, produce node report, integrated report, and then print reports. Most likely they are functions, okay, that need or it has a task to do, or it has a task to finish, okay, something like that. So yeah, and then here is the arrow wherein dictating that this is the flow of the program from here, going there, going up, then going down. Start to end. Okay. So yeah, are we clear with this data flow diagram of a design report generator?
Yes, sir.
Now, this is one example of a data flow diagram, but we have another representation of data flow diagram, which is under, again, it's under software requirements. Sequence icon. Set one. Oh, we don't have BFD. Functional. Use case. Contextual. All right. So I thought we have another version or way of doing that data flow diagram, but it seems that this one is similar with the flow chart. So I was about to say it's the flow chart, but I remember that flow chart is completely different because this one is quite ambiguous or weirder, or it's harder to analyze. So if I were you guys, just use flowchart instead of a data flow diagram, because this one is kind of similar. It is depicting where or how does your uh, uh, program work, okay, in the sense that it's function by function and so on and so forth. And then similar with the similar in some, because when start and then the end for the future, but the others are not that similar. Anyway, so yeah, this is the flow, I mean the diagram of a data flow. So moving on. Okay, so this is a continuation, but data dictionaries, well, of course, this one came from the database itself, wherein when we say dictionaries, it's the terminologies, the variables, the names or the dates that you have used, or the types of data that you have used under this program or under this one diagram. Okay, so for example, this one is the uh, a name, okay, and then under this the dictionary, of course, you can sort that one, okay, from maybe alphabetically. Okay. So yeah, it's the list of all data elements appearing in your DFD model under this data flow diagram of theirs. Okay. Call that one data dictionaries. And structure charts. So I have already explained this one. So this one is actually like uh, yeah, structure chart, but applying a coupled, okay, coupled, call this one, coupled module, okay, or coupled modularity, right? So it is using an arrow wherein this one means needs a data from here to there, okay, and then this one is control data wherein it needs to verify that data first before it will be able to send by here, okay. So yeah, and then some are tightly or highly coupled wherein once you have sent a data, okay, then it will return or it will give back a data also, okay. So this one is an example of a structured chart. Okay, so you guys already know this one. This is the level one, this is the level two, and then the level three. So this is the main project, separating into, let's say, three partition or three part. See this part right here, and then another part right here, and then another part. And then that subcomponent has another subcomponent, which is now the level three. Okay. So I will not read this one anymore since it's very straightforward. And yeah, these are just some notations. So this one is a module, this one is just an arrow, this one is data couple, wherein again it needs a data or it will send a specific data to this module from this module to module. And then a control flag is wherein you need to verify something first before it can send that data. Okay, so this one is similar with restricting the user to input uh, some symbols. Okay, so for username and password, of course, symbols are not, or special symbols rather, are not accepted. So it has to be verified first if that text or yeah, text or character is really valid or no. Okay, so control flag, and then we have loop. So loop is very obvious, and then decision. So it's just a matter of yes or no. And then lastly is pseudocode. The pseudocode decisions can be used in both preliminary and legal design using pieces. Uh, Using pseudocode, the design will describe system characteristic using short, concise English language pieces that are structured by keywords such as if, then, else, while, do, and then end. So I'm pretty sure that you guys already know what a pseudocode is. Wherein this by, or it's actually a readable, okay, readable format of your system, okay, with the use of if, then, else, while, do, and then end. Okay, so not specifically or not the entire code of your program, but just some part of it with the use of these keywords. Okay. And then we now have here the last topic, if I'm not mistaken. Yeah, number 5, which is the object-oriented design. So if you guys are already done with the OOP, the object-oriented programming, the very introduction of that one, this is the similar with that one. It's just that in here we call this one object-oriented design. So in the object-oriented design method, the system is viewed as a collection of objects or entities. Okay, the state is distributed among the objects, and each object handles its state data. So for example, in a library automation software, each library representative may be a separate object with its data and function to operate on this data. So the task defined for one purpose cannot refer or change data of the objects. So objects have their internal data which represent their state, etc., etc., etc. Okay, so the main, oops, I'll just summarize this one since it's kind of similar with uh, integrating an object or integrating a certain entity or data into another a module. Okay, so in here we have from the first one is the object, the most or the smallest data that you can integrate or you can call this one that you can actually couple. Okay, so this one is similar with the coupled, like you are getting the object from another module and then sending it or uh, putting it into another module. So the next one is classes. So classes has functions. Okay, so that's comprises classes. Object could be just a variable or a function. Okay, but class is now the entirety of the module. Then we also have here messages and then abstraction, encapsulation, and inheritance, which needs to be discussed by reading this description because this one now is not common, okay, because we only integrate objects like variables, global variables, and then classes or the functions, okay. But when see messages, objects communicate by message passing. So messages consist of the integrity of the target object, the name of the requested operation, and any other action needed to perform the function. So messages are often implemented as procedure or function calls. Okay, so still kind of similar with this classes, which composes of, I mean, object rather, which is could be a function. Okay, but object is like a general term in such an entity, so it could be a variable only. But when C messages, it is now specifically talking the function itself. Okay, not just the one object, okay, but the function itself. Okay, so those are the differences. And abstraction in object-oriented design, complexity is handled using abstraction. Abstraction is the removal of the irrelevant and amplification of the essentials. So just another type for in dealing or handling problems or complexity. Okay, so just by removing those unnecessary functions or objects, so we call that one abstraction. Okay, so I guess this one now is more like tips, okay, or technique in order for you to make your project more simpler and then more straightforward to the user. Okay, so we call it one abstraction. So removal of irrelevant and amplification of the essentials. And then we also have here encapsulation is also called an information hiding concept. So this one is similar with the information hiding. Where is that one? The one that we have discussed a while ago, wherein you don't need to declare everything global if it's only needed on that module, then do not declare that one as global. So we call that one encapsulation to avoid uh, future problem in terms of security. Okay. This link to is found this information object developers. Here. So this is where I saw the word restrict. So it restricts the access to the data and methods from the outside world or from the other modules. So if you only need to encapsulate two modules with each other, then just encapsulate those two. So you don't need to encapsulate three or four or five if the other module doesn't need that specific data or specific function. Okay, so information hiding is like similar with encapsulation. And then inheritance in object-oriented design allows similar classes to stack up in a hierarchical manner where the lower or subclasses can import, implement, and reuse allowed variables and functions from their immediate superclasses. So this one is similar with function call, okay, wherein you can reuse allowed variables or yeah, similar with the messages or objects where you can reuse those variables or functions. So just by calling them, okay. So this one is called inheritance. So we could see that when we say inheritance, it's the combination of messages and then objects. Okay. And then the last one is polymorphism. So this one is situational. So this one provides a mechanism where methods performing similar tasks but vary in arguments. So in most cases, this one is not used. Okay, but maybe in some instances or cases, this one will be useful, wherein you're using, let's say, similar data or same data, but it will give you different outputs, okay, or different result. Okay, so similar tasks but vary in arguments. So maybe in here you need to have a result of whole number only, but in here you need to get the decimal also. So yeah, same result, but this one just have lesser data compared to this one. It's something like that. Okay. So this is known as polymorphism. Okay. So with that, you're able to save a few lines of codes, I guess. Okay, instead of declaring that variable again, but you actually need the same, let's say, input or the same variable, then you can just use that one. Okay. Anyway, so yeah, that's called polymorphism. Same task, but maybe a little bit different in terms of output. Oh, my apologies. So that is not the last one. So still have the very last one, which is the user interface design. Anyway, this one is now very easy. So we have two parts, okay, or two types rather in a user interface design. We have the text-based user interface wherein it's only using a keyboard. So when you see Unix, it is similar with our CMD, wherein we can, we only deal with our keyboards to do some tasks or uh, functions. Okay. Well, GUI or graphical user interface relies much more heavily on the mouse. So, well, actually, GI is a combination of, or let's say, 10% of the text-based user interface, since we still need to use our keyboard. But yeah, this one is heavily using our mind with the use of the mouse. So just like what I'm doing right now. So this is the graphical user interface wherein I'm using my mouse to navigate, to do some tasks, some functionalities, etc., etc. Okay. And I guess for the GUI characteristics, I guess there's no need to explain those anymore since they are already very straightforward. Okay. And here are some advantages and disadvantages. So less expert knowledge is required to use it. Of course, for the oops, did I skip the advantages and disadvantages of this one? Well, anyway, let's go back to the advantages and disadvantages of the text base. Of course, many and easier to customizations options, and then typically capable of more important tasks. Okay, if you're going to use the text-based user interface, but most of us now are um, more using the GUI, since this one is a lot easier, okay, than using the text-based user interface or just like a Unix. So this one is actually difficult to navigate if you didn't start in, or if you're not used, okay, in navigating with just the use of your keyboard. Okay. So here are some disadvantages. It relies heavily on recall rather than recognition. Navigation is often, of course, more difficult. Okay, while in GUI, so this one is less expert knowledge. So just by, because we can see that the mouse will move if I move my hand. So yeah, less expert knowledge and easier to navigate and can look through folders quickly in a guess and check manner. The user may switch quickly from one task to another and can interact with several different applications. But of course, it also has some disadvantages like typically decrease the options. Okay, since whatever you are, you can only see, that is the only thing that you can click, that you can check. But with the use of keyboard, you can use shortcuts. Okay? You can use combinations of your keyboards to access something. Okay, so yeah, still shortcuts. And lastly, usually less customizable, not easy to use one button for tons of different variations. Unlike in keyboard, we have different combinations, different shortcuts for us to do, like Control R is to go to run. What else? Alt tab, yeah, Alt tab to move to another application, from one application to application. Alt F4 to close a certain application. Okay, so yeah, those are the advantages of text-based over the GUI, right? And then here are the UI design principles. Wherein this one is a very straightforward already. In of course, we have the structure. Whatever we are seeing here right now is the structure of the GUI. Okay, it is organized. Uh, it's meaningful and usual based and precise. It's consistent. So yeah, that's structure. And then simplicity, of course, the more the simple the interface, the better. So in other words, like a friendly user. Okay, easy to navigate, easy to see the languages, easy to see things, etc., etc. Visibility. So very straightforward. So the design should make all required options and materials for a given function visible, of course. So that is why we have some, colors right here to make this word home announcement modules visible. Because if they've used white, then it's like, we are not seeing anything in here anymore. Okay. So visibility. And then feedback. Of course, in most cases, if you need to report the problem, then you should have the feedback option in everything. Okay, like for example, maybe here in Canvas. So maybe here has the community, so you can, or here report the problem. Okay, so you can send a feedback to the developer, okay, of this canvas or of this website right here. Just let them know that there is some functions or some maybe I don't know, maybe buttons that doesn't work really well. So feedback. And then lastly is tolerance. What if the user accidentally click this button? Will it give you an error? What if I went to history and then click something that is that I should have not, or that I shouldn't click? Okay, will it give me an error? Something like that. So everything that I must do, okay, on this graphical user interface must be, must be okay. Must not give me an error. It must not give me a bug. Okay, so it should be able to tolerate misuse, okay, of the user, right? Well, except by, deleting some files in local disk or in your operating system, then that's of course it cannot tolerate those kind of actions anymore. Okay, anyway, so yeah, that's already it for the module 3. So we still have 6 minutes left. So anyone who has a question or a clarification so far?
None, sir.
All right. What about the others?
None, sir.
Answer.
Okay, so let's move on now to the last last one, which is the assessment part. So in here, you're going to a a data flow diagram and the dictionaries of your project. Okay, so whatever is your proposal in software design laboratory, create a data flow diagram of it, and then the data dictionaries of it. Okay, and then submit it here before March 14th. So you guys have 2 weeks from now to finish this task right here. It's function oriented design. Okay, so are we clear with your next task or next activity?
Yes, sir.
Yes, sir.
All right, so if you have a question, just let me know, okay? And then don't forget to send also your individual evaluation of your group meets. So I gave you guys 2 days time, to finalize everything. Okay, so right after you submitted your work, then that's the time that you must rate your agreement. And then for the last one, is the case study. So you guys already know what to do with this one. Just read the facts and then just answer this question. So again, there is no incorrect answer as long as you were able to convince me that your answer is really correct, and then you were able to justify your answer. Okay. So yeah, that's all for now for the week 7 and 8, and then we'll just discuss this one next week, okay, week 9 and 10. So we'll try to finish the modules as early as possible so that the remaining time or remaining days, remaining days that we have will be used as your time to finish the project. Okay. So yeah, that's all for now. And still have 3 minutes left. So I guess you guys don't have any question anymore. So you guys may go now, and as always, thank you guys for coming. I really appreciate it, especially those students of mine who have stayed from start to end. Okay, so before we were around maybe 11 or 10, but right now it's now just 8. So thank you for those who have stayed. So goodbye, and let's just meet again next week.
Bye, sir.
Thank
Goodbye.
you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you to you.